This lecture is going to be on air masses. Air masses have very specific characteristics. So during this, we're going to be able to explain what an air mass is. We'll be able to describe how air masses are classified, and we'll be able to describe the general weather associated with each type of air mass. Now if I look at this picture, I've got all these labels, and you'll see that a lowercase letter next to a capital letter, and they all mean something. This is going to be what we're going to be making sense of, because where we live and where we're affected here in the Chicagoland area, we're going to have some very specific air masses that are going to be, let's just say, affecting our weather. So it is important to make sure we describe where the air is coming from. Is it coming from the north? Is it coming from the northwest, southwest? What part of the southwest? Is it coming from the southeast, etc.? Then we're going to describe what is allowing the air to gain its characteristics. We're going to be able to name the air mass and the conditions of the air within the picture. So we'll come back to this. So air masses. The characteristics, these are large bodies of air. They're about 1,600, right, about 1,000 miles or more across. They're several kilometers thick. A similar temperature at any given altitude. In other words, we're going to say that they have very homogeneous characteristics. They're very much the same. There's similar moisture at any given altitude, and they move and affect large portions of the continent. So the source region is very important. This is the area where an air mass acquires its properties. We're going to be using a couple different explanations. Continental versus maritime. Does it form over land or water? Continental, it's going to form over land, and maritime is going to form over water. Is it polar or tropical? What latitude does it originate? If it's polar, it's going to be coming from the north. If it's tropical, it's going to be coming from the south. So together, we're going to be putting these together, and we're going to determine, is it continental polar, is it continental tropical, is it maritime polar, or is it maritime tropical? So here's what we'll look at. During the winter patterns, we generally get air from continental polar. It's cold and it's dry. Sometimes we get continental Arctic, very cold, very dry. Sometimes we get maritime polar, cool and humid. Sometimes we get maritime tropical, which is warm and humid. And sometimes we get the Gulf warmth, which is also maritime tropical, warm and humid. The summer patterns, we're going to look at, sometimes we get continental tropical, that's very hot, very dry air. So, but often we get maritime tropical. We'll be talking about this, and we're going to be looking at how it collides with either continental polar, cold and dry, or maritime polar, cool and humid. So we need to get into this, and we'll start looking at the air mass itself. So air masses, the classification of the air mass, there's two criteria. One is the latitude of the source region. That polar come from high latitudes, and they're generally cold. That tropical come from lower latitudes, right, closer to the equator, and are warm. A second criteria is going to be the nature of the source region itself. That continental forms over land and is generally dry. And maritime forms over water, and it's going to be humid. It's going to have moisture available. So the two features are the latitude of the source region and the nature of the surface in which the source region in which it was found. So latitude and where. So in this case right here, we're going to be able to determine if it's over land, it's going to be drier. If it's over water, it's going to be more moist. So there's four basic types. We've got continental polar, small c, capital P. We have continental tropical, small c, big T. Maritime polar, small m, big P. And maritime tropical, small m, big T. Now these are four primaries, not the only four. These are the ones we'll look at. So in the Midwest, we're going to look at continental polar, maritime tropical. These air masses are the most important air masses in North America, especially east of the Rockies. So if this is my Rockies here, especially locally to us. Continental polar, maritime tropical. Continental polar, these come from northern Canada and the interior of Alaska. In the winter, these bring cold, dry air. In the summer, they bring cool relief. These are responsible for lake effect snow. So we'll end this lecture with lake effect snow. Continental polar air mass crosses the Great Lake. So let's go back and look at the picture here. So if we assume that the lake effect snow is coming from continental polar here, that the cold, dry air coming out of Canada is going to pick up moisture from the lake, and the snow is going to occur then on the leeward side of the shores. So that's the far side. So in the direction of the air mass movement is going to then deposit the snow. So we'll get into the lake effect snow here very, very briefly toward the end of the lecture. So back to maritime tropical. So maritime tropical here, notice, is coming from over a body of water, M, and tropical towards a lower latitude, whereas the last slide we're looking at continental polar, right? The air gets its properties from over land and from a higher latitude. So moving on to maritime tropical. So these come from the Gulf of Mexico and the Atlantic Ocean, right? These are the air masses. They're warm, moist, and generally unstable air. They bring precipitation to the eastern part of the United States. Continental tropical, right? Small c, capital T, is from the southwest in Mexico. Very hot, very dry. Seldom important outside of the source region. So in other words, we don't really get a whole lot of continental tropical effects. So maritime polar, small m, capital P. These bring precipitation to the western mountains. So when I look at these are going to be the Pacific Northwest, this area up here. Occasionally they influence the northeastern United States, and they cause what are called nor'easters in New England with cold temperatures and snow. So nor'easters, we'll talk about those very, very briefly. So let's get into what happens and when it happens when we have a really cold Canadian air mass. And notice how cold this originates, and as it travels through the kind of the central plains here, that it seems like it's getting warmer, but it's still extremely cold. So it's not warming, it's just getting to a lower latitude. And when this cold air mass travels over the Great Lakes, something happens. That continental polar or even continental Arctic air, either one of these, notice that we have two different air masses we can reference here. We can say continental polar, cold and dry, or continental Arctic, very cold, very dry. That both of those have a tendency of finding their way to our local area. So when the continental polar or continental Arctic air mass moves southward from Canada over Lake Michigan, or any and all of the Great Lakes, Lake Michigan provides both the warmth and the moisture for cloud development. Warmer air rises, condenses adiabatically, and snow results due to the cold atmospheric conditions, right? This is what leads to snow. As the continental polar or continental Arctic air mass advances, it continues to deposit snow on the leeward side of the direction of the air mass is traveling. So if I have land here, it's cold air, it's going to be picking up the water vapor from over Lake Michigan. So notice that as it begins to build, right, the clouds build, it's going to then eventually, by the time it reaches land, it's going to be able to have very heavy lake effect snows. The Lake Michigan, or the lake itself, is providing both the warmth and the moisture. So two factors together. Cold, dry air moves over the lake. The lake provides the conditions that have that air mass then acquire these snow conditions that then snows on the leeward side. And here's a map that we have that we can make sense of. That if you look at this, where we see the darker blues, we get the lake effect snow, and these generally occur in what we call bands. Now, even though we're not in a band per se right here, I mean, we're in this green one, which generally 36 to 59 inches probably is a little bit much for us. We don't generally get that much. But anyway, I didn't make the graph. I just want to make sure you reference it. Even though we're not considered in the highest bands, we're in a pretty significant band, right? You've probably heard of northwestern Indiana getting a lot of the lake effect snow. But look at the leeward side of all the Great Lakes. That's where you get your highest concentrations of lake effect snow. So having said that, lake effect snow, we get this cold air mass moving through, rolls over. The Great Lakes are what provides both the moisture and the temperatures, the warmth, that then evolve into these snow conditions. And that is lake effect snow.